Hello, how are you guys doing?
I'm good. How are you?
Fine, thank you. Hope you can hear me, see the screen. All right. Now, I'm gonna start by taking you to the class so you can see my announcement. Excuse me. Let me see if I can open it from here. What happened to my class? Okay, I'm gonna put it right here. So this is first of all, let me start by saying that no need to come to class on Thursday. So this will be our last class session so that you have time to prepare for your final exam. I'm going to make a final exam available Sunday by midnight so you can take it by the due date. In the meantime, here are the assignments that I do this week. Homework 9, which is you have been there anyway. I just extended it to this week. The homework 10 is what we are going to cover now this afternoon. How to how to solve the questions, the kind of question you see on that homework. Then project. Now, I have made your project available. Now, you can just have access to it by going to the modules and then scroll down to where you can see right here. When you click on it, you'll see the project. I want you to follow the direction religiously. Follow it exactly the way I explained it. Watch this video and follow the directions to complete the project and then submit. Read the instructions so that you know what I require for this. Watch the video. In the video, I did a sample. You can use it as a guide for you to complete. Now, there's something I want to update in what I just said. Actually, homework 10 is for regression and correlation. So I'm going to put a video, put it on the announcement. Watch the video and use it to as a guide to complete homework 10. It's not really something big. It's some work you're doing. You can use Excel to finish it, to complete it and submit. Yeah, in my lab and mastering. Sorry, my lab and mastering. Yes. So the questions are there, but you can use Excel to answer those questions. Now, it's homework 9 that hypothesis testing that we are covering tonight, this afternoon. We started it last week. I introduced you to how to state hypotheses and some of the concepts about hypothesis testing. Today we'll start the actual hypothesis testing. Okay. The good news that we have Excel, it make it easy for us to use. And if you follow my method in this how I demonstrate it, I guarantee you're not going to have a problem. Now, don't forget, I'm going to post the video that you watch before you do homework 10, okay? There's no classwork, and then let's begin. Like I said, last week I introduced you to hypothesis testing. Today we're going to do Z-test for the mean and T-test for the mean. There are two methods, actually. There's one they call the traditional method, whereby we make decision based on the critical values. Okay. Then there's another type is that we call the one that you see most of them in some most statistical packages, the p-value method. Excuse me. Let me make sure I have this. Yep. The p-value method. Okay. In the p-value method, some reason I come here, this thing will allow me to, okay. In the p-value method, as you can see on the screen, we make decision based on the p-value. So I'm going to explain it in a minute. Now, let's go to the first of all, the Z-test for the mean. The process involve stating the hypothesis and identifying your claim, which we did last week. I showed you how to state hypothesis and identify your claim. Next is to find the critical values. using the table. We are going to be finding the critical values using Excel. And I'm going to show you in a minute. Let's say that the alpha is let's say that the alpha is equals 0.05, for example, or 0.01, for example, no matter what it is, and they ask to find the critical value. Alpha. Let me say I have as a find the critical value for alpha 0.01 left tail, for example. Left tail. I have the formulas, the Excel formulas you can use here. And I have it for the T test. I have the Excel formulas here as well. And so in any case, for left tail, the formula is right here. If you say left tail, formula you're gonna use is equals norm dot s dot imv, okay, then the alpha inside. Okay, so make both of them to be as 18 font size 18. So all of them are here. I have this form uploaded for you in the model, so you can have it there. So now this is the formula you use, and this is the alpha that you are given. They ask to find the critical value for alpha 0.01. For example, I'm going to take you to Excel, left tail. Okay. For example, you can come here. Let me see if I can put it here. 0.01, so that the critical value, okay, will be if you look at that form, it said the formula for Excel formula in that I just showed you, it says norm.s.inverse alpha. So that means you gotta be simply put that formula here equals norm.s.inverse. It will pop out here. Double click. Oh, excuse me, excuse me. Norm.s.inverse. Then double click on it. Then click on alpha. Close the parentheses and press the enter key. It will give you the critical value right away. Normally, we have leave it in two decimal places. You can just reduce it to two decimal places, 2.33. And if it is left tail, you just do equals norm.s.imv, double click on this. Oh, sorry, my mistake. 1 minus is 1 minus alpha. So do put 1 first, put minus before you click on alpha, close the parentheses, and press the enter key to give you the same thing. Say that it will be positive this time. Okay, excuse me. Okay, so that's how I find the critical value. And I have all the formulas here for you. And also in the model, so you can just print it out. So if you see a question in the homework that say find the critical value, use any of these formulas here. If it is for t-test, use any of these formulas here. Okay. Now, having said that, we can go back to where we have today. So for the z-test steps, state the hypothesis and identify your claim. Okay. Then find the critical value from the using Excel. We're not using table. You can also use table if you want. I explained that table when we were doing confidence interval. I said I showed you that table when we were doing a normal distribution. Then compute the test value. This is the formula you use to compute the test value. Z equals x bar minus mean divided by standard deviation by square root of n, where S bar represents the sample mean, mu represents the population mean, delta represents the population standard deviation, and n represents the sample size. Then once you get the test value, then the answer you got from that test value, you compare it to the critical value. If it's bigger than the critical value, you reject the null hypothesis. If it is less than the critical value, you do not reject. So look at that's what I wrote here. The decision criteria is this: reject null hypothesis if and only if the calculated value, that means your answer, is equal to or exceed critical value. Then after that, you can now make a summarize your result. Now, this is for the traditional method. Now, if you're using the p-value method, it's something, this is almost the same thing, except that this time you are making decision based on the p-value. First of all, state the hypothesis, identify a claim, compute the test value, find the p-value, not the critical value this time, find the p-value. Then compare the p-value to the alpha. If the p-value is less than alpha, you reject null hypothesis. If it's bigger than alpha, you don't reject. And then make a decision and summarize the result. So look at the decision criteria if you're using the p-value. I've already said it, but I wrote it here anyway. If the p-value is less than or equal to alpha, reject null hypothesis. If the p-value is greater than alpha, do not reject null hypothesis. So the opposite of critical value method. The good news is that Excel gives us the result for both methods. So when you do one example, you have already done the traditional method, and you have the result for traditional method, and you have the result for p-value. So you can choose what method you want to make a decision. So even if a question say use the p-value method, just do it in Excel, and then you should pick the p-value from Excel. Just round it to normal decimal, the number of decimal places they require. That's all. Okay, guys. So let's try example here. Look at the example we're gonna try. Maybe one example or two. Let's try this one. It says here that yeah, for some reason if I come here, it won't allow me to have my cursor showing. Okay. It says here that a researcher okay, this researcher says, oh, excuse me. A researcher report that average annual salary for assistant professors in the year 1997. Make sure I'm seeing this. Okay, good. Okay, is it's more than 42,000. A sample of 30 assistant professors has a mean salary of 43,260, and they say at alpha 0.05, test the claim that the assistant professors earned more than 42,000 a year in 1997. The standard deviation of the population is 5,230. So what we're gonna do now is first thing is to state the hypothesis. I'm gonna bring by my cursor here again. It's gonna allow me to put this right here. Why is my cursor? Okay, good. So let's first of all state the hypothesis and identify our claim. Okay. Like I said, I should have to state hypothesis last week. HO, we need HO, which is null hypothesis, and H1, which is alternative. I want to make this sense to be font of 18, font size of 18. So I'm gonna make it 18 font size. Okay. So now HO, the keyword here, it says that the researcher report that average annual salary of assistant professors in 1997 is more than, say, it's more than 42,000. See, it's more than. So that means more than means greater than, and you can only use greater than in the alternative. So you have mean, okay, mean is greater than 42,000, Okay. That is your claim. Claim. That's the claim right there. Now, the null hypothesis and alternative as a hypothesis, they say things that are opposite of each other. So the HO would now become that it would have been that mean is less than $42,000. But the problem is that you cannot use less than symbol in the null. You can only use less than or equal to. So you're gonna use mean is less than or equal to 42,000. Okay. Here, and the alpha is said, they say that the alpha for this is 0.05. Okay, 0.05 alpha. And because see, if you look at the claim, you can see that the symbol greater than is pointing on the right side. So this is a right third test. Right third test. If you remember, if it, like I explained last week, if it is pointing on the left side, it becomes a left third test. If it doesn't point at any particular side, it becomes two tests. Like if I use the equal to and not equal to, it becomes a two-third test. Anyway, next is to write down our summary statistics for this. The summary statistics they give us from the equation is that the researchers reported the average annual salary of assistant professors in 1997 is greater than 42,000. So we're gonna be using that here. I missed my cursor again. Yeah, that page doesn't allow me to use my cursor. I don't know why. Okay, let me go back there again. Okay, I'm gonna go back there again. So let's put the first thing we need to put there is the mean. In putting the summary statistics together is so the sample mean equals 2,000. So we're gonna just copy it from here and change that to equal sign. So writing down the summary statistics. Sorry, not the sample mean, the population mean equals 42,000. And it says here that a sample of 30 assistant professors. So N sample size equals 30 assistant professors. Then we have our that the so that the sample of 30 assistant professors has a mean salary of 43,260. So our X bar sample mean X bar equals. So I'm gonna put the bar on it somehow. So I'm gonna put the bar on it. X bar, put the bar equals it says that it is 43,260. Okay. And then the standard deviation is say the population standard deviation is 5,230. So I'm gonna put the population standard deviation delta as 5,000 is right here, 5,230, 5,230. Okay. So it doesn't change to triangle. I'm gonna update it with this. Okay. So that's our summary statistics, which I would like to put in give us font size of make it them to be 18 font size. So I'm gonna have this. So I'm sure you're seeing the screen. Now we're gonna use this to run the test in Excel. So let me write them down here. Population mean, which is this one, right here, is 42,000. Sample size is this one, okay, is 30. Then sample mean, X bar, is 43,260. And sample standard deviation is 5,230. With this, we are ready to go to Excel and then run the test. Okay. So I'm going to take you to Excel and say, let's put all these things in. Okay. So taking you to Excel now. All right. We're here. So I'm going to put those numbers. Sample mean, population mean is 42,000. Okay. Sample mean X bar is 43,260. Population standard deviation is 5,230. Sample sizes 30. Now, there's one problem here with Excel. Excel doesn't have I would say, should I call it a package for doing one sample z-test? They have one for two sample tests. Not only that, when you are doing any statistical test in Excel, Excel want raw data. What we have here is summary statistics. We don't have the raw data. So what we're going to do, we're going to trick Excel to believe that to fit that we are using a two-tailed test, and then that we're doing using a raw summary statistics raw data. We trick it. They play a trick on it, and they say we not believe that he's actually working with he's actually working with two sample test of hypothesis, that it is doing two sample test of hypothesis. But actually, what it will generate will be the result for a one sample. Then after that, we update. Okay. So now, since we don't have the raw data, you see this place, type in observation. Since there are 30 assistant professors selected, you can either type 1 through 30 here, or you can just make it faster by typing 1 here, and then use the formula to finish the put equal, click on this +1. That means everything will be added to 1. 1 will add it to any number. So then you can drag it all the way to once you get to 30. Okay. So since there are 30 assistant professors, if there are 40 assistant professors, then drag it to 40. Depending on what the question said. Now for the data, we use the sample mean here that it asks us. They say that if you look at the original question, it says here that a researcher report that the average annual salary of assistant professors in 1997 is more than 42,000. Then a sample of 30 assistant professors has a mean salary of 43,260. So this is what you're going to use to trick Excel to believe that it is working on raw data. So we're going to use this 43,000, this sample mean of 43,260. Put it beside those observations, okay? 43,000, okay, 260. Then you can copy it all the way down. Just bring this cursor close to this place. Click, hold and drag, or just double click. It will copy it all the way down to the 30th number, okay? Now, since Excel doesn't have the package for doing one sample z-test, now let us trick it to believe that it is doing two samples by putting a dummy variable. Dummy variable, put 0. So since there's no second sample, so put a 0 there. That will trick Excel. Now, once you have it, you're ready to run the test. Okay. So let us run the test now. Click on data here, data analysis, and scroll all the way down to where we have z-test, two sample for means. Click on that and click OK. Okay. Now for the variable one range, use the data. That is the means this data here. Click on it and then drag it down to the last one. Or you can just click on it and press Control Shift and downward arrow. It will copy the whole of them right here. Okay. And then, okay, the next thing is it has copied it there. Next is for the variable to range, use the dummy variable. Okay, right here. Okay, click on this. Now, for the hypothesized mean difference, you're gonna use this, which is 42,000. That is in the hypothesis where you stated the hypothesis. 42,000. Now, variable one variance. Now, that's the variance for this. Now, we are told that the standard deviation is 5,230. So, variance is, for variance, you square the standard deviation. Like, if you have the variance and you want to get the standard deviation, then you take the square root of the variance. But if they give you the standard deviation, and what you are looking for is to find the variance, you square the standard deviation. So that means you're going to square this and put it here. Okay. So to do that, I'm going to do it in with our Desmos calculator. I got the so I have it here. Okay, let me see. I think I opened it. Okay, let me see. Okay, let me put it right here. Desmos. Are you sure? I think I have it. Yeah, I have it right here. Okay, so let me share it. Share Desmos. So we're gonna put the standard deviation. I mean, here I'm square it. 525,230 square it. Square right here. Gave me 27 million. So I'm gonna make it 27 million. Okay, you can see here. 352,900. So that's what I'm gonna enter there. Okay. With our Excel right here. Okay, let me do it again. Excel, this right here. Okay, Excel. Okay, we are in Excel now. So now click on this and put it right in variable one for the variable one variance. Type in the answer we just got, which is 27,352,900. Now for the dummy variable, there's really no variable here because it's 0. But if you put 0 for the variable 2 variance, Excel will not accept it. So what you're gonna do is put a number that is really very small but close to 0, something like 0.00001. Very small and very close to 0. Excel will accept this one. Now, when I was picking the variable range, I click on the data and the dummy at the labels. So I'm gonna check the labels. Now, our alpha is what's our alpha again? In the question, the alpha is 0.05. Okay, so I'm gonna go to Excel again. Okay, and then put 0.05 right here. Oh, it's there already. But if it's not there, just remove it and put it. Let's say that you are using alpha of 0.01, then you change this to 0.01. Now for the output, I'm gonna put the output probably right here. Okay. So we have everything in. We're almost done. Just click OK now. It will give us the result. Now, it will give us the result as two sample z-test. Two sample z-test. Okay. Let's see, give me 1 minute. Okay, here. Two sample z-test. So we're gonna update this to one sample. So I'm gonna remove this because we have tricked it. It thinks that it was doing two sample, but it's one sample. One sample. Then, because it thought it was doing two sample, it says hypothesized mean difference, not move the difference. And this dummy bad column, you remove it because we don't need it. Okay, we just remove it. Delete. Okay, and then so you can see the result right here. This is the result we have gotten from the output. So let me make it make all this result, this one to be two decimal places. For Z formula this is the test statistic here. Usually we use two decimal places. This is the p-value. So he gave us the result. He gave us the p-value. He gave us the test statistic. And this is a left right there. He gave us one. See 1/3. This is p-value for 1/3. Right here. Okay, I'm gonna just use a light green to highlight that. Then he also give us the critical value for 1/3. So basically it's 2 in 1. Yeah, even though you are doing 1/3, you give us result for 2/3. Even though we are doing the traditional method, you give us the result for both the traditional method and the p-value method. So now I'm going to highlight this. Well, I'll put the critical value for 1/3, make it 2 decimal places, because you normally have 2 decimal places, or maybe 3 decimal places. Then I have p-value, left it for 4 decimal places. So I'm gonna highlight this, make it look more beautiful, just like this. Then I'm gonna do Control C, copy it, and go to our main workbook to paste it, so we can make our decision and conclusion. So we have run the test. This is the result we got. I'm gonna push it down here, make it a little bit bigger, probably 16. Okay. Now let's make our decision. Okay. Our critical value is 1.65. Critical we got I'm gonna give me 1 minute. Critical value equals, we have it right here, 1.645. 1.645. The calculated answer we have value equals right here, Z, 1.32. Note that this calculated value is answer we will have gotten if we have used this formula here. But I said did it for us, so have it. Now, I remember the decision criteria. It says reject null hypothesis if and only if the calculated value is equal to or less than the critical value. So here, we have this is the critical value, this is the calculated value. Hold on, let me go back to that statement again. It says reject null hypothesis if the calculated value is equal to or exceeds the critical value, not less than. So this is the critical value right here, and this is the calculated value, which is less than the critical value. So do not reject. So do not reject. Do not reject HO, because the calculated value of 1.32 is less than the critical value of 1.645. So we do not reject. We then reject the hypothesis. That means we do not reject, this is not hypothesis here, that mean is less than 42,000. Then, so we do not reject it. That means we are not accepting this claim. Means that the claim is not correct. So there is we can now make our conclusion by stating that conclusion here will be, okay, there is insufficient evidence to support the claim that, okay, that assistant professors earned more than $42,000 in 1997. Okay, and that's it. So basically, you make a hypothesis, identify a claim, put the summary statistics in Excel, get the result, paste it, or just leave it in Excel. Choose make a decision. Now, suppose if you want to, this is the way of making decision if you're using the traditional method. Suppose you want to make you're using the p-value method and you want to use it to make decision. Again, what you're gonna do is just simple. Decision, if you're using the decision using p-value method. Okay. In that case, yeah, p-value, okay, equals okay, p-value equals and what you have here, p-value. This is the p-value for 1 tail. So this is the right tail. If you're using, if it is 2 tails, I mean, use this p-value right here. But this is the right tail. It's a 1 tail test. So it's p-value is 0.0935 rounded. 0.0935. Of course, you know that it is 0.093491. So you round it to 0.0935. Usually four numbers is better. 4 digits. Okay. Now the critical value, I mean the alpha. What's an alpha? In this case, I'm using alpha to compare. Alpha is alpha equals 0.05. You can see that the p-value is bigger than alpha. See, bigger than alpha. So if you look at it, remember the decision criteria, you're using the p-value method. Say if the p-value is less than or equal to alpha, reject no hypothesis. But if the p-value is greater than alpha, do not reject no hypothesis. So here the p-value is bigger than alpha. Say do not reject the null hypothesis. See, that is if you're using the p-value methods, which and then the same conclusion will be used since you did not reject it. There is insufficient evidence to support the claim that assistant professors earned more than $42,000 a year in 1997. Does anybody have a question on this?
No.
Okay, good. Now, this is for z-test for the mean when we know the value of the population standard deviation. Sometimes we don't know the population standard deviation and the sample size is small. Here, the sample size is 30. Usually, statistically, when it's 30 or more, we say it's large. But suppose that we don't know the value of the population standard deviation, and in addition, the sample size is small. So in that case, we use what is called the t-distribution method. Right here, t-test for the mean. So the t-test for the mean is a statistical test for the mean of a population, and it's used when the population is normally or approximately normally distributed, but the population standard deviation is unknown, and the sample size is small, which is when we say the sample size is small, we're talking about less than 30. Okay. Now, for that case, this is the same process. State the hypothesis, identify the claim, get the critical value, and then go from there. But the difference that we are now using a sample standard deviation S. So you can see the formula T equals S bar minus mean divided by the standard deviation by the square root of n. And where S bar is the sample mean is population mean, S is the sample standard deviation, N is the sample size, and then the degree of freedom is this one is based on degree of freedom. So degree of freedom is n minus 1. So we use n minus 1 to find the degree of freedom, where n is sample size. And now, for this type, Excel doesn't really have the package for the T distribution where we have summary statistics. So we can use a old school method to do it, and making it old school method. Let's try it. It says a job placement director claimed that the average starting salary for nurses in the year 2000 is $24,000. A sample of 10 nurses has a mean salary of $23,450, and the standard deviation of $400. Is there enough evidence to reject the director's claim at alpha 0.01? So the first thing is to state the hypothesis. But before I do that, remember this is 10 nurses, so sample size is small. And for that sample of 10, we have an average of 23,450. And there's sample standard deviation of 400. So this is a good candidate for T test. So we got HO and H1. And the keyword there is say that a job placement director claims that the average starting salary for nurses in 2000 is 24,000. Is means equal, and we can only use equal in the null hypothesis. So you have the hypothesis mean equal 24,000. Claim, it's a claim right there. And the alternative say the opposite of that, which mean, okay, is not equal to 24,000. And the alpha, we are told that the alpha is 0.05. So I want to make all these things to be less bold. Okay. Now we can now have our summary statistics. Okay. So the population mean is 42,000. I can just copy it from here and paste it right here. And then the sample mean is what the sample mean? Sample mean is 23,000. So I'm gonna sample mean before I write that, let me put the sample size of 10, where n equals 10 nurses. You can get the degree of freedom is df equals 10 n minus 1, which is 10 minus 1 equals 9 degrees of freedom. Okay. Now we have a sample mean x bar equals, so I'm going to make it x bar somehow, make it x bar right here. Be careful. Okay. Equals, according to this, is 23,450. $23,450. With the sample standard deviation of 400, which is S, which presents sample standard deviation of 400. So I'm going to write this down so we can now go and get it. But before I do that, I want to get a critical value. Now, since our excuse me, sorry. Since our degree of freedom is 9, our critical value T, critical value is T. Since this is a 2-tailed test, so it's a T alpha over 2, right? You can get it from Excel, over 2 equals. Now, if you remember the command that I mentioned before, this is a 2-tailed test. For T gonna be the command. Let me write the command under so you can just put it right here. It's equals. The second command we're gonna use it equals. We have T dot inverse, okay, dot 2T, okay. They have our alpha, okay, a comma, and then we have our degree of freedom df. TF. Close it. That will give us the answer. Let me write the summary statistics down. Then we can go in Excel, get the critical value, and we can now, after that, we can now use this formula to find to run the test. Since Excel doesn't have for t-test doesn't have the package for using the summary statistics to, I can't trick it. I was able to trick it with using if it's a z-test. For t-test, I couldn't figure it out. So let's use the old school method, but use the Excel to find the critical value. So we have a sample mean. Let's make sure you're seeing this. All this. Okay. Sample mean is 24,000. Sample size is 10. X bar is 23,450. Then sample standard deviation is 400. Degree of freedom is 9. DF is 9. Alpha is 0.05. Okay. So we are going to be using the formula for the t-test. But let us get put this and get the degree of freedom first. I mean the critical value first. So for that, I can just take you to Excel here. Since we know that alpha, we know alpha. So you can just put equal t dot inverse. Okay, so it's inverse dot 2t. It will pop out right here. Double click. Say alpha is 0.05, comma, and the degree of freedom is 9. Close the parenthesis, press enter key, and that'll give us 2.26. 2.26. Let me write it down here. T alpha over 2 equals 2.262. We call it 262. Doesn't matter. 2.262. So that we have it right here in the summary statistics. 2 point. No, note that it is two sides. So if the left, if it's on the left side, you're gonna be negative 2.262. If on the right side, you're gonna be positive 2.262. And don't forget that, okay? But what we're using is the absolute value, actually, of the result. So now let us run the test. So I'm gonna take you to the workbook where it will allow me to put the formula. When I say the formula, I'm referring to this one here, TS by C. So let's go and put, as a matter of fact, I can copy it from here and paste it in that workbook. So let's go over there. After we bring our result back here. So I'm going to insert equation. I'm going to paste it right there. Okay. Now make it a bigger. Make it 20. So it's big enough for us. Okay. Excellent. Equal. So I'm going to put this. Remember we have our summary statistics. Let me refresh our memory with those again. We have our population mean to be for $24,000. N is 10. Sample mean X bar is 23,450, and sample standard deviation is 400. So use it to, put them in the formula. Okay. We have S bar is 23,000. I wrote some paper. 450. Oh, excuse me, 450. Minus meal, that's this one right here, is 24,000 divided by standard deviation by root n. Sample standard deviation of 400. What the square root of n? N is 10 nurses, I believe. So let's go, and I'm going to make this unbold it. Yeah, I'm going to unbold it. So I'm going to go to the write it down, go to our this most calculator to find it. 23,450 minus 24,000 over 400 with a square root of 10. Okay. Let me take it to the calculator. So you got 23,450 minus 24,000 divided by standard deviation of 400 over the square root of 10. Like me, negative 4.35. Negative 4.35. Okay. Okay, negative 4.35. Negative 4.35. I'll copy this. Yeah. Copy it and Control C. Then go to main workbook and put it right there. Control V. Now let us make a decision. Decision. Okay. Our critical value is 2.262. Critical value equals 2.262. Okay. Then we have calculated value is negative 4.35. Remember, we are using the absolute value for them because negative 4.35 just that it is on the show that it's on the left side. That's all. So just by symmetry, it's going to be 4.35. So we have the calculated value. Calculated value equals negative 4.35, which is basically if you put the absolute value of that. Let me make all these things to be on bottom. Make sure I've seen this. Yeah, good. If you get the absolute value of this, so now put it right here. The absolute value of this. Okay. Okay. Which is 4.35. The absolute value of any number is positive, 4.35. If you compare them, you can see that the answer we get from their calculation is bigger than the critical value. So we reject, reject the null hypothesis since 4.35 is greater than the critical value of 2.262. Okay, so we'll reject null hypothesis because of that. So our conclusion now becomes conclusion equals that if you look at the hypothesis, this is the claim is a null hypothesis. We are rejecting this. So that means the claim is not correct. So there's not like we don't have enough evidence. There's not enough evidence to support the claim that the we don't have enough evidence to support the claim that the average salary of assistant professors is more than 24,000. So they say there is not enough evidence to support they claim that assistant professors, sorry, my mistake. There's not enough evidence to support the claim that the average starting salary for nurses in year 2000 is $24,000. Again, any question on that? Any question, guys? Okay, no question. Good. Now, for this one, they give you the numbers, the list. All you have to do is to use Excel to find the mean, use Excel to find the standard deviation. And since there are how many of them? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So that means the sample size is 8. N is 8. Use Excel to find the mean, use Excel to find the standard deviation, and then follow the same step we have here to run that test. Now, we're not going to do test of hypothesis for proportion for this class. So what we're going to do is the regression and correlation. Okay. Now I have, like I said, I'm going to have this video link. Just watch this video and then use it as a guide to answer the question on homework 10, and then you'll be good. Okay. In that video, I saw 2 examples, these 2 videos. One for simple linear regression and correlation, and the other one for multiple. So watch it and then use it to solve it. And remember, no need to come to class on Thursday. This is our last class. And then we are done for the day. So I see you, well, I will say, I'm gonna see the work you completed and grade them, okay? Any question before we leave?
No, you said that you posted the final exam and the instructions are there, right?
No, you're talking about the project.
Yeah, the project, my bad.
Yes, it's there now. The final exam,
Okay, thank you.
I'm going to make the final exam available in my lab and mastering on Sunday night. So you just like you take you take your tests,
Okay, and are you still grading the extra credit assignments?
Yeah, I'm still grading it.
Okay.
And when I finish, I do it student by student.
Okay.
All
I
right,
have a question too.
yes, ma'am.
I know you had said I could do the work, and I did it, and I emailed you, but you never responded. So
If you have
did you get it?
If you have done the work and emailed it to me, and if you follow my instruction to send it to my email, then it's there.
Okay, because I just want to make sure you got it, because
just have to be
I
patient.
did it before the due date.
Yeah, good, very good.
Okay.
Just have
Thank
to,
you.
Yeah, you're welcome.
Wait, and you said, I'm sorry, I keep interrupting. You said on Thursday you would help us with the project that's coming up too?
No, I'm not helping with project. I already have it here. I have a video for you to watch that I made myself.
I didn't see the video when I went to the assignment. I just seen you say the video, but I didn't see it on there.
If you give me 1 minute.
Okay.
If you go to the class, scroll down to module 8, see the project right here. Can you see the screen?
Yeah, I can see it. I just, when I pressed on it, I didn't see your YouTube video like I usually do. Okay, it's there. Okay. I see it now.
Okay.
All right, thank you.
Welcome. All right, guys, have a nice day.
Well, I have a question.
You too.
Yes, ma'am.
So the final project considered the actual final, or is just separate?
It's a project. Final exam is final exam. Final project is final project. There are 2 separate things.
Okay. So the final exam is on lab and mastering?
Yeah, I'm gonna put it there on Sunday, midnight Sunday. So you can complete it before the due date.
Okay. Thank you.
Welcome.
Yes, I had a question as well. Well, not really a question, more so of a statement. I know last class I did inform you that I sent you an email. You said that you were going to look at the email, but you did not respond back to the email. So I was just like reiterating the email that I had sent. Kendi Holland, you wrote my name down.
Yes, I did. What happened? I think let me see. I think yes. Is it possible to tell me now here?
Yeah, That's fine. Let me just go back to the email that I sent so I'm saying the right things for the right assignment.
Yeah,
One, I'm
go,
sorry.
go ahead, ma'am.
Oh, so so it was the test 2.
How come you didn't put it on the 5 assignment that I say make up?
No, so the test 2 was something that happened after because that wasn't a part of the makeup.
Yeah, but with Holland, I can't go more. Remember, I said it in the class. I can't go beyond 5 assignments. I'm so sorry.
No, so
Go ahead.
but it wasn't a makeup assignment. So the concern was I sent you an email saying
Is it a technology issue?
Yes, I was actively completing the test and it had timed out and I didn't even finish the questions. And so it had graded my assignment without me like finishing and it affected.
Okay.
Yeah, so I was
You know what?
wondering
Stay right here. If it's
okay.
the tech issue, right?
Yes, that was the problem. It wasn't that it was late or overdue. I was actively completing the assignment before the due date and I was not able to.
The tech issue then. Test 2, right? Test 2.
Yes, it was test 2.
Test 2. Let's see what we can do. I got tons of email, Miss Holland.
Yeah, I know.
I'm behind in all of them. Behind in all of them, Miss. That's probably why I didn't. It's what's the name again? Holland, right?
Yes, Holland is the last name.
Holland. How come your name is? Oh, right here. Your name is here already. Holland. Okay. Now, Candy Holland. And it's test. It's test. Okay. Test 2, right?
Yes, test 2.
So you have to complete it by Thursday.
Okay, no problem.
I can't give you more than that. Thursday is May. Thursday will be, today is 6th. Thursday is 8th. Don't miss it, Miss Holland. No, this is last chance, okay?
Yes, thank you.
You're welcome. I have it. It's there now for you. All right. Have a nice day.
Thank you so much. You have a nice day as well.
You too.